Welcome to another deep dive into the world of robotics. We've got some pretty cool research papers and articles lined up for you today. I'm actually really excited to get into this one,
Oh, yeah. It's a field that just keeps pushing the boundaries of what's possible?
for sure. And today we're going to zero in on something pretty revolutionary. It has the potential to change how we think about robot control altogether. It's called hover.
Yes, Hover. That's right. It's a neural whole body controller developed by NVIDIA, and they're working with several universities on this. It's really all about giving humanoid robots a level of versatility. I mean, a level we haven't really seen before.
So what we're talking about is robots that can switch between tasks seamlessly, like picking up an object carefully 1 minute and then navigating some crazy obstacle course the next. And all of this is thanks to this one adaptable control system. That's pretty much the promise of HOVer, right?
That's exactly it. One of the biggest hurdles in robotics has always been, well, traditional control systems, they often need separate sets of instructions for every single task. We call these policies. And this really limits how adaptable a robot can be.
It just seems so inefficient. Like imagine having to relearn how to walk every time you wanted to go to a different room. Hover kind of sidesteps that whole issue, doesn't
It
it?
does. It uses something called full body kinematic motion imitation. It's like a universal language for any task you can imagine.
Okay, I'm intrigued. What does that actually look like?
Well, think of it like this. You could teach a robot an intricate dance routine, and then it could adapt those very same movements to all sorts of different situations. Grasping objects, navigating obstacles, you name it.
So the robot learns this foundational set of movements, becomes like a toolbox that it can draw from to solve all kinds of problems.
A great analogy. Now, on the technical side, Hover is initially trained by something we call an oracle policy.
Oracle policy.
Interesting. You can think of it like a master teacher guiding a student. In this case, the student is the Hover system.
So this oracle is showing Hover the ropes, and it learns by watching.
Exactly. But it goes beyond just observation. Remember proprioception, the robot's sense of its own body.
Right. It's like how
Yeah.
we can sense where our hands are even without looking at them.
That's it. That internal awareness is absolutely key for complex movement. And to make things even more refined, they use command masking.
Command masking. Fill me in on that one.
Okay, imagine you're trying to learn something new, but there's just noise and distractions everywhere. Focusing is hard, right?
Oh, for sure.
Well, command masking does that for Hover. It filters out all the unnecessary noise and helps the system zero in on the crucial commands for each task.
So it's all about prioritizing the important stuff and tuning out the rest. Makes sense. Especially for a robot trying to pull off these complex actions.
Absolutely. And this brings us to all the different control modes that Hover can handle. The visuals you've got actually do a great job of showing this off.
Yeah, these visuals are pretty incredible. We've got right-hand mode, two-hand mode, left-hand mode. It's amazing to see how the robot can manipulate objects using one or both hands.
And then there's head mode. The robot can control its head movements so precisely, perfect for tasks where visual focus is key.
And then we have some really interesting names, H2O mode and Omni H2O mode. These make me think of underwater applications.
Right. And then there's X-body mode and human plus mode, hints at robots interacting directly with humans, maybe even augmenting human capabilities.
It's really something to see how hover can just flow between all these modes. It almost reminds me of a dancer moving from one step to the next, like the X-body H2O switch or the human plus Omni H2O switch. They really show off that seamless adaptability.
It is impressive, and what's even more amazing is that Hover can work with a variety of command types.
So it's not just about these different modes. It's about understanding different kinds of instructions, too. What kind of commands are we talking about here?
Well, you've got kinematic position tracking, basically getting to a specific point in space, like a robotic arm reaching for a tool.
So you're giving the robot coordinates for his hand to reach?
Precisely. Then there's local joint angle tracking, more about moving specific joints to precise angles. Think about handling delicate instruments. This is where that comes in.
So it's like fine-tuning the position of individual parts of the robot.
Exactly. And then finally, there's route tracking. This controls the robot's overall position and orientation in its environment, crucial for navigating tight spaces or uneven terrain.
The possibilities are pretty mind-blowing when you think about it. Robots assisting with surgeries, exploring dangerous environments, even working with humans in complex manufacturing. This could be a real game changer.
It really could. And we're just scratching the surface of what might be possible with systems like this.
This is just the beginning. So much more to uncover. We'll dive even deeper into the potential impact and the research behind Azure in the next part of our deep dive.
You know what I find really fascinating about Hover? It's how it uses this motion imitation thing.
Mm.
Like, it's a common thread for all these wildly different tasks.
It's like, what if learning a crazy dance routine
Hmm.
could somehow give you skills in like sports or painting or even folding laundry?
Yeah, that's a really good way to put it. By turning these complex actions into this language of movement, Hover brings a level of adaptability that we've just never seen in robotics before.
Okay, but how does that actually work in real life? Like, how do you go from a robot that can dance to one that can assist in surgery?
Right. Well, that's where the Oracle policy comes in. Remember, we talked about it earlier. It's
Yeah.
like Hover's master teacher, showing it all the right moves and actions.
So is it like there's this super skill robot that already knows how to do all these things, and Hover's just watching and learning from this expert robot?
You could think of it that way, yeah.
No.
But it's not just passively watching. Remember proprioception, the robot's sense of its own body.
Right. So Hover is aware of where all its limbs are and how they're moving as it's learning from the Oracle.
Exactly. That self-awareness is crucial for any kind of complex movement, especially when you're talking about a robot out in the real world where precision is key.
And then there's command masking. You mentioned that earlier. Can you refresh my memory on how that fits in?
Sure thing. Remember how we talked about filtering out distractions? Well, Hover doesn't have to process every single command all the time. That would be super inefficient. Command masking helps Hover prioritize. It lets it focus on the most relevant commands for whatever it's doing.
So it's like a mental filter for the robot. Helps it stay on track.
Exactly. By activating different command spaces selectively, Hover can switch between modes seamlessly and adapt to all sorts of situations.
This is all seriously impressive. But I have to ask, what does this actually mean for the average person? How will hover-like systems actually impact our lives?
That's the million-dollar question. It's definitely sparking a lot of excitement, and maybe a little caution, too.
Yeah, I can see that. Robots have always had this weird place in our minds. We're fascinated by them, but sometimes they kind of creep us out too.
True. But with Hover, we're talking about a whole other level of sophistication and adaptability. These aren't just mindless machines following orders. They can learn, adapt, maybe even collaborate with us in totally new ways.
So are we talking about a future where robots are more like partners than tools?
Exactly. Imagine robots helping surgeons with these crazy complicated procedures, or exploring places that are too dangerous for humans, or working right alongside us in factories, making our jobs safer and more efficient.
It's a future with a ton of potential. But let's back up for a second and talk about the research behind all of this. Who are the masterminds who made this innovation possible?
The team behind Hover is pretty amazing. You've got robotics experts from NVIDIA, known for their AI and graphics processing, and then researchers from top universities. Carnegie Mellon, UC Berkeley, UT, Austin, UC San Diego.
Wow, that's quite the roster. It sounds like a real collaboration between academia and industry.
It really is, and that's often where we see the biggest breakthroughs. So where do you think this is all heading? What's next for Hover and for robotics in general?
Tough to say for sure. But I think we'll see these robots doing even more complex and subtle tasks, things that require dexterity, adaptability, even creativity.
I could see that happening. I also think we'll see robots that can interact with us more naturally and intuitively. Robots that understand our emotions, anticipate our needs, learn from our behavior.
That's exciting and a little bit unnerving at the same time. Feels like we're on the cusp of a major shift in how we interact with machines.
I agree. There's a huge range of possibilities. And it's important to recognize both the potential benefits and the challenges that come with this level of tech. But for now, why don't we switch gears and really dig into those research papers you brought?
Sounds good. Let's take a closer look at how Haver actually manages to achieve this level of performance. Wow. These papers really dive deep into the complexity of what this team has pulled off with Haver.
It's really remarkable how they've brought together so many different elements of robotics, motion planning, machine learning, you name it.
And the results are right there in front of us. The level of performance they've achieved with Haver is pretty mind-blowing.
Yeah. One thing that really caught my eye was their focus on proprioceptive feedback. You can tell that the robot's ability to actually sense its own body position is a major factor in how well it performs.
Yeah, it makes perfect sense. I mean, if you don't even know where your limbs are in space, it's got to be pretty tough to move with any kind of precision or grace.
Exactly. And what's even cooler is that Hover can adapt to changes in its environment, even damage to its own body.
The paper mentions this one experiment where they messed with the robot, they restricted one of its joints, And Hover was still able to figure it out and complete the task.
It really speaks to the robustness of the system. It's not just blindly following some set of instructions. It's learning and adapting in real time.
That kind of adaptability is going to be huge as robots move out of the lab and into the real world. I mean, things are unpredictable out there.
Totally. And that leads us to another exciting aspect of Hover, its potential for real-world applications.
And the possibilities seem endless. We've touched on some of them, but it's worth really hammering home just how transformative this technology could be.
Oh, absolutely. Imagine robots working side by side with humans. In factories, on construction sites, even in disaster relief, they could take on dangerous or repetitive tasks, freeing up humans to focus on more creative or specialized work.
And think about healthcare. Robots like Hover could be helping surgeons with these super delicate procedures, providing physical therapy or even caring for the elderly.
The potential upsides are enormous, but of course we can't ignore the potential challenges either.
Right. Whenever you have a technology this powerful, there are going to be concerns.
For sure. One concern is the impact on jobs. As robots become more capable, they might start taking over jobs that are currently done by humans.
That's a valid point, and it's something we need to approach carefully. But we also have to remember that technology has always disrupted the job market.
That's true. Throughout history, automation has actually led to the creation of new jobs and entire industries. It's all about being prepared for those shifts, investing in education and training programs that give people the skills they need for the jobs of the future.
Couldn't agree more. We need to be proactive about adapting to these changes and making sure that everyone benefits from technological advancements.
And beyond job displacement, there are also concerns about safety and control. As robots become more autonomous, we have to have strong safeguards in place to prevent accidents or misuse.
Absolutely. We need to make sure these robots are designed and used responsibly, with human well-being as the top priority.
Those are all crucial points, and they highlight the need for open and honest conversations between researchers, policymakers, and the public.
We need to talk about the potential benefits and risks of this tech and work together to build a future where robots actually enhance our lives in positive ways.
Well put. And I think that's a great place to wrap things up. We've explored the incredible potential of Hover, we dug into the technical details, and we considered the broader impact of this groundbreaking technology.
It's been an amazing deep dive, and I feel like we both learned a lot along the way.
Me too. I hope our listeners now have a better understanding of this exciting world of robotics and the transformative possibilities of systems like AFER.
To everyone listening, we encourage you to keep exploring this topic and to join the conversation about the future of robotics.
The future is being shaped right now, and it's up to all of us to make sure it's a future where humans and robots can work together to build a better world.
Thanks for joining us for this deep dive.